Number 6 from the exponent stencil. You're given, in brackets, negative 9 times a squared times x squared, all of which is to the power of 3, times 3 squared times a. Now, the first step I'm going to do is rewrite what's inside my bracket to something that I can use more effectively. I notice that negative 9 I can rewrite as negative 1 times 9 times a squared times x squared bracket to the power of 3 times 3 squared times a. Also, I know that 9 can be written as 3 squared, so this is equal to negative 1 times 3 squared times a squared times x squared cubed times 3 squared times a. Now the reason I rewrote my 9 as 3 to the power of 2 is because I see over here that there's another 3 to the power of 2, which means later when I multiply the two together, because I'll have the same base, a base of 3, I'll be able to add the exponents, hence reduce the term even further. So now what I do is I distribute this 3 into my bracket, and so this 3 actually comes here over the negative 1, here to the 3 to the power 2, a to the power 2, and x squared. So what this gives me is negative 1 to the power of 3 is still negative 1 times 3. Now I'm using power to a power rule, and when I have a power to a power, I multiply the exponents. So 3 to the power of 6 times a to the 6 times x to the 6. Now I have no more need for brackets, I don't write them, times 3 squared times a. Now because multiplication like this is commutative, I'm going to group the like terms. The 3's with the 3's, the a's with the a's, the x's with the x's. So negative 1 hangs out in front. 3 to the 6 times 3 squared times a to the 6 times a times x to the 6. This is equal to negative 1 times 3, 6 to, times 3, 2. I add the exponents. That gives me 3 to the 8 times a to the 7. I add the 6 and the 1. And all this times x to the power of 6. This finally gives me a final answer of negative 3 to the 8 a7 x6. Now I could have done this a bit faster. I didn't have to commute my terms in this step over here. I didn't have to. If I know that I can add them, I can go straight and skip this step. But I did this step just to show you that the process of commutativity is important, and that's how we group our terms together.